So now I think we're ready to try these problems. The first problem was number 13. What is the wavelength of an electron moving at 1/100th the speed of light? So the speed of light is, we said we're going to use 3.00 times 10 to the 8th meters per second. So we would say speed of light, 3.00 times 10 to the 8th meters per second. So moving down here, if I type in 3 times 10 to the 8th, 3EE8, remember the EE key? Notice I did not press times 10. I didn't use 10 to the x. I said 3EE, 10 to the 8th. So 3EE8. I'm going to divide that by 100. So I end up with 3 times 10 to the 6th. So 1/100th, the speed of light, is 3 times 10 to the 6th meters per second. Okay, that's our speed. So we had an equation that in order to do wavelength, we need to know frequency. We don't know frequency, but we have an equation that deals with mass. The mass of an electron, if you remember. We looked that up on Siri one day in class. So I'm going to go ahead and write that equation down and then substitute in the numbers. So the wavelength is equal to h divided by mass times velocity. So we don't know wavelength. We know h is 6.63 times 10 to the negative 34th joules per hertz. We know the mass is 9.11 times 10 to the negative 31st kilograms. I'm going to let you look that up again, but if you need to verify that, or you can just take my word for it, but you would need to look that up or know the mass of an electron. I got it by just doing research on it, just doing an internet search. And that would be, kilograms. All right, put those in. All right, and then the velocity we just figured out is 3 times 10 to the 8th meters per second. No, 3 times 10 to the 6th meters per second. Oops. I'm a little out of room over here. Remember, that's meters per second. All right, so to solve this, you're going to multiply these numbers together, or divide. Just do this math. It's not very hard now. So we're going to take our 6.63 EE 34, but it's a negative 34th. Notice I put the negative sign, and notice also that you use this positive negative, not that one. Okay, divided by 9.11 times 10 to the negative 31st. So you use the EE again. 31st, and then put a negative sign. If you have a different calculator, you may need to hit the negative sign first. Okay, then I'm going to divide it again. Uh-oh. Oh, that's kind of weird. Why is it not a number? It is a number. So 6.63 EE negative 34th divided by not a number. 6.63 EE 34 and the negative sign divided by it's essentially zeros, right? But it's still a number. So 6.63 times 10 to the negative 34th divided by 9.11 EE 31. Okay, gonna have to use a different calculator because this calculator is not cutting it. All right, let's try that. So 6.63 times 10 to the negative 34th. There should be a little positive negative sign here. If there's not, we'll have to use the negative sign that's here. Nope, that didn't do it. That did it. Okay. So 6.63 times 10 to the negative 34th. That was divided by 9.11 times 10 to the negative 31st. And that was divided by 3 times 10 to the 6th. Remember the 3 times 10 to the 6th? Which the 1/100th of the speed of light. And that all equals 2.43 times 10 to the negative 10th. So our final answer here would be 2.43 times 10 to the negative 10th. Okay, number 14. Oh, by the way, that would be meters only. All right, here, real quick, here's why it's meters only. The units on this thing, you have joules per hertz on top. And that was divided by kilograms and meters per second. Okay, so those are all of our units. Now, since a joule per hertz is really a joule per 1 over S, and that's over a kilogram meters per second, a joule per 1 over S is the same thing as a joule times S over 1 divided by kilogram meters per second, which is really then a joule second times second over kilogram meters. For the same reason, when you divide, this is a fraction, that's a fraction, when you divide fraction, you multiply by the reciprocal. Okay, so that equals a joule second squared per kilogram meter. Now come on down here. So a joule is a Newton meter. Remember from last year in physics, a joule is a unit of energy or unit of work. So it's a Newton meter second squared over kilogram meter, and there's where our first meter goes away. So now we've got a Newton second squared per kilogram. But a Newton, you remember from last year, is a force, and a force is force times mass times acceleration, so it's a kilogram meter per second squared times second squared over, so a Newton is that, over kilograms. Now look what happens. Second squareds go away. That leaves us with kilogram meters over kilograms, and kilograms go away, which leaves us with meters. And that's why the wavelength is in meters. All right, now this next question, if it has a mass of 1,500 kilograms and a wavelength of 7.75 times 10 to the negative 39th meters, what is the speed? So how fast is it moving? So I'd use the same equation. Lambda is equal to h over mv. So you'd have 6.63 times 10 to the negative 34th joule seconds. I won't run through the units again this time. The units all are, you have to think about all this stuff to get the units to cancel out. The mass is 1,500 kilograms, and the mass has to be in kilograms because of the Newton being a kilogram meter per second squared. So you need kilograms to cancel. We don't know the velocity, so we're looking for that. So put a v there. Notice that's a v, not a nu. And the wavelength is 7.75 times 10 to the negative 39th meters. All right, so to solve this equation, the first thing you have to do is get the denominator out, get the variable out of the denominator. So you're going to multiply both sides by 1500 V. And over here, you're going to multiply by 1500 V. It's common for not to realize that that denominator has to be cleared, but you've got to get the variable out of the denominator. All right, so now we just go ahead and do the math. I'm going to go back to my online calculator, which outperformed my Apple calculator, it looks like. Seems to be hiding on me. There it is. Oh, I put it down at the bottom of the page. That's why it's hiding on me. It was there all the time. All right, so here's my calculator. So we have, since the variable now is going to be on this side, I'm going to go ahead and take this number and divide by that and divide by that. So I'm going to have 6.63 times 10 to the negative 34th divided by 7.75 times 10 to the negative 39th divided by 1500. So here we go. 6.63. Notice the EXP key, negative 34th divided by 1500 divided by 7.75 times 10 to the negative 39th. That seems, okay, so 1500 meters per second. Did I make a mistake on that? No, that's right. That's probably right. So 57, the answer would be 57 meters per second. Okay, now we want to know what is in miles per hour. So I'm going to go ahead and do that on the other piece of paper. So I got 57 meters per second. I'm going to change to miles per hour. Now, this is just a dimensional analysis problem. I was trying to remind you how to do that. So 57 meters on the bottom, kilometers on the top. So 1 kilometer is 1,000 meters. You can look this up, but a mile, 1 mile is 1.61 kilometers. And then we need to go seconds in an hour. So we put seconds on the top, hours on the bottom. 60 times 60, 60 seconds in a minute, and 60 minutes in an hour. So you've got 3,600 seconds in an hour. Oops. So now we close these windows up, close that up. And run this calculation real quick. So the answer would be 57 times 3,600. Then I would divide by 1,000. And I would divide by 1.61. And it turns out to be 127 miles an hour. Okay, so there's the answer to that one. Okay, the third math question. What's the wavelength of an electron which has a mass of 9.11 times 10 to the negative 19th nanograms and travels at 2 times 10 to the 8th meters per second? All right, and I told you those relationships here. So the wavelength of an electron, which has a mass of, which equation are you going to use? You want to find wavelength, right? So wavelength is equal to h divided by mass over velocity. So that's equal to 6.63 times 10 to the negative 34th joules per second, or joule seconds, not joules per second, joule second, joules per hertz, which converts to joule seconds. We have we got to change that. So it's 9.11 times 10 to the negative 19th nanograms. I'm going to go ahead and change that over here. What's it need to be changed to? That'd be kilograms. So you'd have nanograms here, you'd have grams here, you'd have grams here, you'd have kilograms there. Which is bigger? Grams, so 1 times 10 to the 9th, and then 1 over 1,000. So that comes out to be 9.11 times 10 to the negative 31st kilograms. You can check the math if you want. And then the mass, that was the mass, sorry, and the velocity is 2.00 times 10 to the 8th. And that would be in what unit? Meters per second. All right, so you're gonna have kilogram meters per second, you have joules seconds, you have joules seconds squared. It goes through that whole thing we went through a minute ago. The final answer on this one, yeah, let me work it out. I think I know the final answer, but I'll just double check. So 6.63 exp negative 34th divided by 9.11 exp negative 31 divided by 2 exp 8 equals, 3.64 times 10 to the negative 12th. Okay, so that's all the math questions. Wavelength is measured in meters, and the units will all cancel out into meters like I showed you earlier. Okay, now electron has a value of 3. What's an N have to be? Or has an L value of 3. So if L equals 3, N has to be at least what? So remember, L can be 0 to N minus 1, so it has to be at least 4. It could be 4 or anything greater. Looks like I've been talking too long. My battery's going to run dead here. All right, a valence electron in an atom of potassium has an M value of positive 1/2. What are the other 3 quantum numbers? Well, here we go. Potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, if it's a valence electron, that tells you that we're talking about this electron. So what are the quantum numbers? N equals 4. L for an s sublevel equals 0. If L equals 0, there's only one M value, and that's 0 also. So M equals 0. So it's 400. So the 4 quantum numbers for that electron would be 400 positive 1/2. So that's the end of that sheet. I think I'll go through this next sheet real quickly on a separate video. So we'll stop this one. I'll plug my battery in.